Hello everybody. Today we're going to study how to solve radical inequalities. So basically a radical inequality looks just like a radical equation, but it has a symbol like greater than or equal to or less than. So that's what we're going to be looking at. Let's look at our steps. So first of all, we have to look at the index of the root and see if it's even, and identify all of the values that would make the radicand non-negative. In other words, we have to take the value under the radical and set it to be greater than or equal to 0. Otherwise, we know if we take the square root of a negative number, we do not get a real solution. We get an imaginary one. And we're only looking for real solutions here. The next step is to solve the inequality algebraically, just like we solved our inequalities. And then, of course, we have to test values to see if where our solution is going to land. So we have an example up here. Notice the first thing, we take the value under the radical and we set it to be greater than or equal to 0, and we solve. And what we find out is that x has to be bigger than or equal to negative 1/5 in order for the value under the radical to be at least 0. Now that we know that, we're going to go ahead and solve. So we solve the equation. Notice that we move the 5 over and then divide out. So it would have been -8. We divide out the negative, and then we square each side, and we get 20x plus 4 equals 64. Solve, 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 and we get x is less than or equal to 3. So now what we're going to do is we're going to test values. So if you can think about the number line, we have negative 1/5 here. Usually like to put 0 on the number line. And then we have 3 over here. So we can do a couple of things here. We can look at our number line and we can choose values to the left, between, and to the right of our value, and we can test them. So in this example, they chose -1 as the value to the left of negative 1/5. So when you put -1 in, what you find out is, well, it doesn't satisfy this equation. We get a negative number under the radical, so that is not part of the solution. Testing between negative 1/5 and 0, the easiest number is to substitute 0 in. When we substitute that value in, we find out that, yes, that does work. We get 3 equals 3. Or I'm sorry, we get 3, okay? And 3 is bigger than -3. So that worked. So this area right in here, those numbers, are all part of our solution set. And then when we test to the right of 3, they just put a 4 in there, we get about -4.2. And what we know is -4.2 is not bigger than or equal to -3 from our original inequality, so that doesn't make sense. So our solution lands between and including -1/5 and 3. So this is written in set builder notation. We can also write it how I prefer for you to write it, which is using interval notation. So from -1/5 to 3, including both -1/5 and 3. So let's go ahead and let's do a couple of problems together. So step number 1, we have to take 2x minus 1, which is our radicand, and set it to be greater than or equal to 0, and solve. When we solve that, we're going to add 1 to each side and divide by 2. So we get x is greater than or equal to 1/2. Okay, we'll leave that there. And now we'll look at solving our inequality. So what we're going to do is we're going to subtract 6 from each side. So we get 3 times the square root of 2x minus 1 is less than 9. And then divide by 3 on each side. And we get the square root of 2x minus 1 is less than 3. Okay, we know in order to undo taking the square root, we square each side. So we get 2x minus 1 is less than 9. And we solve this two-step inequality. We add 1 to each side, which gives us 10, and divide by 2, and we get x is less than 5. So let's go to the number line. Okay, we're going to have 5 over here. We'll have 1/2 over here, and like I said, I always like to drop 0 on the number line. So we must test to the left of the 1/2, between the 1/2 and 5, and then to the right of 5. So I'm going to test 0 first of all. Okay, so check 0. And we would have 3 times the square root of 2 times 0 is 0 minus 1 plus 6 is less than 15. Well, we can't take the square root of -1 and get a real answer. So this is not part of our solution. Now let's test between 1/2 and 5. So you can pick any number. I think 1 is the easiest number to check. So check 1, and we get 3 times the square root of 2 times 1 is 2, minus 1 is 1, plus 6 is less than 15. 3 times 1 is 3, plus 6, we get 9 is less than 15. That is a true statement. And what that means is all of the values in here will work. Okay, and notice that this said greater than or equal to 1/2, so this would be a closed circle on 1/2. Now we have to check to the right of 5, so I'm just going to put 6. So we get 3 times the square root of 2 times 6 is 12, minus 1 is 11, plus 6 is less than 15. And so we're going to have to do a little math here, a little estimating. So we have 3 times the square root of 11 plus 6 gives us approximately 15.9. And we know that 15.9 is not less than 15. So this answer here and all of the numbers to the right of 5 do not work. So it says x is less than 5, so this would be an open circle. And this is the region right here where all of the values that would work in this inequality land. So using set builder notation, I would write it like this. Bracket 1/2 to 5, and then a parenthesis because that indicates that the 5 is not included in the solution. Okay, so I think what you should do right now is pause the video, go ahead and try number 2, and then turn the video back on and see if you were able to do it as I am. So go ahead and turn that video off and see what you can do on your own. So let's take a look. So first thing we did, we have to set the radicand to be greater than or equal to 0 and solve. So we wind up with x has to be bigger than or equal to -9/10. So that's one restriction. Then we have to go ahead and we have to solve our inequality. So I added 2 to each side and squared both sides. Subtracted 9, divided by 10, and we get x is bigger than 4. So looking at this, now I decided to check, once I put my numbers on the number line, I decided to check -1, I decided to check 0, and then I looked at 5, and I tested all of those values. So for the first one, for x equals -1, what we got was a square root of a negative. So this will not be part of our solution. When I checked 0, I got a statement that said 1 is bigger than 5. Well, that's not true. 1 is not bigger than 5. So that is not part of our solution. And on the third one, when I checked 5, I got approximately 5.7 is bigger than 5. And that is true. So that means our solution goes from the numbers that are bigger than 4 Okay, remember we go back to this, bigger than 4 to infinity. And using interval notation, we would use parentheses, 4 comma infinity, and another parenthesis because we can't quite reach infinity. Okay, so hopefully this was helpful, and hopefully you'll be able to do the rest of your assignment with no problem. Have a great day, everybody.